Okay, good morning, listeners, grade 12s. My name is Bongani Ebet Manganyi. So you are more than welcome to join us to SmartCaps. That is the physical science that we're just going to look at. But for now, this SmartCaps has been sponsored by VT, that is Vesta Tech and VT Africa Holdings. Okay, we need you to. Okay, before we start or we do anything, we need you to log in. You have to supposed to have a data so that you can just go through for internet. You have to type in www.hellosmart.com to take part in the assessments. Okay, sign up as a guest. Type in your class ID, which is 598751. Add your name. I can repeat this. Log into www.hellosmart.com to take part in the assessments. Sign up as a guest. Type in your class ID 598751. Add your name. I hope you have everything that is needed to your smartphones so that you can be part of today's lesson. Like I said earlier, we're just going to look at the physical science, grade 12s. That is term 2. The topic is work, energy, and power. What I need you to bear in mind, we have work. This is not new to everyone. We know work, you have different definitions, but now we have to look at the scientific definitions. When it comes to physical science of work, we have to look at the energy. I know that from other grades, previous grades, we have different definitions, but now we have to look at the scientific one. And then power is very, very much important, especially to us, because without power, you're not going to see us. Without power, you can't eat. All right. Firstly, you have to look at the definition of work. Obviously, we have work. Work, I can say, is something that has been given to you to do. Given by parents, if you're at home, at work, you have work, they can give you a task that is supposed to complete and the time. But when it comes to scientific definition of work in physical science, work is the product of the force and the distance covered. All right. We all know from first term that we have done forces. We have done forces. We have done distances from other previous grades. But I need you to bear in mind, this work is a scalar quantity. How do you know that it's a scalar quantity? We're just going to look at the different vectors. If you multiply or product of vectors, you're just going to get a scalar quantity. Obviously, you know the definition of a scalar quantity, and this work is going to be measured in joules. Okay, there's a vocabulary. These are very, very much important. We have negative work, is what we are going to cover. We have positive work. We have work itself. We have zero work. These are things that you can just ask yourself. Why are they saying it's negative work? Why are they saying it's positive work? Why work? Why zero work? Okay, there are conditions that we're supposed to look at. When it comes to negative work, energy has been removed. When it comes to negative work, energy has been removed. The energy that has been applied to a certain object, so that is going to cover a certain distance or certain displacement, the energy is going to be removed, can be transferred to heat, can be transferred to sound. And then when it comes to positive, and then before we go to positive, we have to look at the negative again. You have to indicate. When it's negative, you have to put minus to show that this is negative. Okay, we have to look at the positive work. When it comes to positive work, that is the energy transferred to a particular object. This object, it will move to the direction of the force. And then it's going to be indicated by plus. Okay, we have work. That is the product of the force applied to a particular object and the distance covered by a particular object in the direction of the force. Okay, we have zero work. For zero work, there's nothing happened there. There's nothing happened. For instance, if you apply the force to an object is not going to move, there is a zero work. Or if your angle theta is perpendicular, we have vertical, we have horizontal. If it's perpendicular and the angle there is 90, you're just going to get zero work. All right. Okay, this is a table contents, definition of work. We talked about this earlier. And then positive work, we talked about it. We're just going to look at the formative assessment. Of course, you have to bear this in mind, that we are going to have definitions, we are going to have whatever that we're going to do. At the end, we're just going to check whether you are with us or not. Okay, and then we have zero work and negative work. We're just going to look at them as well, and the formative assessments. So you have to be ready with your calculators. You have to be ready with somewhere you can just write so that you can work out when it comes to formative assessments. Okay. All right. At the end, we're just going to finish with the determining the net work done. Okay. When it comes to this, we have to look at the horizontal and vertical. We have horizontal, vertical, and here I need you to remind yourselves about the inclined and all the components that they are taking part on those inclines or horizontal. Okay. This is the definition of work. A work can be done as long as there is a force applied to any object. To any object, you can just pull it, you can push it, but work can be done there. We can just have a positive work, negative work, or zero work if the force applied to a particular object is playing a part or is not. It's where you can talk about zero if it's nothing. And then I need you to bear this in mind. The angle played an important role, the angle theta, between the force and the distance, the motion, the direction. I'm just going to show you soon about that. So you have to think about the unit of work. Work is joules, don't forget that. And then I will show you the formula, mathematical formula of work soon. Okay, definition of work. Have you ever been told that your hard work will pay dividends? Of course, when we grow up, each and everyone, we have been encouraged to work hard. We have been told that, okay, if you can put efforts on this particular work, at the end, you will reap something. As a learner, you have to work hard. You have to study in time so that you can just have a good result at the end. All right. Have you ever told someone that your mom or dad have gone to work. Obviously, everyone knows that each and every day we have to wake up, prepare ourselves to go to work. If you're not going to work, you have to go to school. When you go to school, you are doing your work. Work is everywhere. Work is everywhere. Of course, you're going to cover a particular distance. The moment you cover the distance, there's a work on it. All right. In everyday language, the word work can have many different meanings. Of course, earlier I talked about it's not new to us. Work is everywhere. But what I like in physical science, whatever that you do is work. You learn. When you are working, it's work. You learn. When you are just pointing, moving around, it's also a work. All right. All right. Definition according to scientific gatherings. However, in physics, we define work as follows. If a constant force, obviously you know a constant. If it's constant, it's not changing. Is that clear? It's the same force that you started with. You continue with it until the end. A constant force, this force is going to be represented by capital letter F. If you're using your device, you have to bold it to show that this force is a vector. If you are not doing that, you have to write on top of each and every capital letter F a full arrow or half of an arrow to indicate that this is a vector. Okay, X on M, body while it undergoes a displacement. A displacement then, that is the distance covered. That is the distance covered by a particular object from point A to point B. Okay, then it's going to be denoted by X. That X is a displacement, and displacement is a vector. Don't forget that. In grade 10, you have learned about displacement. One dimension there, they showed, they displayed, everything is from grade 10. Okay, then the work is going to be denoted by capital letter W, done by this force, is defined as follows. This equation here is a mathematical equation. You are going to come across with this at the end of the year, at the back of your question paper. You are going to have this equation, where you must bear in mind, this is a vector. This is a scalar. W stands for work. F stands for force. Change in X, that's a distance covered by a particular object, is a vector because it's a displacement. That is the angle that I talked about. We have to look at the components. This is the angle that you're supposed to look at. There's a force applied and the distance that is going to be covered there. That is why we have cos theta. All right. Now, in order for you to understand this, you have to say a constant force, X on a body while it undergoes a displacement. Then the work done by this force is denoted by this W equals to F, that is the product of the force, displacement, and a particular angle. Okay, as you can see here, we tried to show you how these letters represents. We have F, the magnitude of the force acting on the object. Don't forget that because it's very, very much important. Each and every exam, they can just give you a question. What is the unit of W? If you don't know the unit of force, it's going to be a problem at the end. The force, the unit of force is Newton. Okay, change in X, the magnitude of the displacement of the object measured in meters. That is the distance covered. If you can just look at that, we have small letter m. It's not capital letter M. All right, we have W, the work done by the force on the object measured in joules, represented by capital letter J. All right, we have a theta there. That is the angle between the force applied and the distance covered by an object. Okay, if you can just look at that, we are just going to look at this quite often, this angle, theta, because it's the one that is going to give us the positive, the negative, the zero. Okay. This is very, very much important. I said that earlier. I said work is a scalar quantity and therefore has only magnitude and no direction. Okay. I tried to explain about how are we going to reach to scalar quantity. I said we are going to have a vector and a vector. Because of the force, force is a vector and displacement is also a vector. That is why we are going to get a scalar. All right. What I was saying earlier, I said this theta is very, very much important. It's the one that is going to tell us the positive, negative, and zero. Okay, that is far right there. If you can just look at it, we have this angle, theta, and the force applied, and the distance that is going to be covered in the direction of the force. Okay, the angle theta between the force and the direction of the displacement of the object determines whether energy has been transferred to an object or removed from an object. When it comes to positive one, like I said earlier, the energy has been transferred to an object. Obviously, it's positive. If you can just look at that, we have a direction towards right. You have to choose there from Cartesian plane. You can say on my right hand side is positive, on my left hand side is negative. All right. When energy is transferred to an object, this is very, very much important. I need you to bear this in mind. When energy is transferred to an object, of course, object will move. It will move faster and faster. If it's not constant, is that clear? It will move faster and faster, but it's going to be determined by the force applied to that particular object. And here, in order for you to define a positive work, you have to say when energy is transferred to an object. Positive work has been done on an object. That is the key. All right. To determine whether energy has been transferred, check if the angle between the force and the direction of the displacement of the object is less than 90 degrees. Okay, if it is less than 90 degrees, this means that positive work has been done. Okay, you have to ask yourself, if it's less than 90, in other words, we can have 30, we can have 20, we can have 45, we can have 40, we can have 65, we can have 60, as long as it's less than 90. If it's less than 90, you are going to get a positive work. I hope I'm clear here to everyone. If it's less than, this is a condition for positive work. Theta is less than 90 every time. Don't forget that. Okay. We have to look at this example. We have to look at this example one. A force measuring 150 Newton acts on, this is the angle that I was talking about earlier, 30 degrees to the horizontal on an object. If the object is displayed by 5 meters along a horizontal frictionless surface, how much work is being done by the force? All the time, when you come across with this, you have to start by writing down, jot everything, write a data. What is it given? What are they looking for? Okay, obviously we have what? We have 115 Newton acting. That is the force. We have angle. That is 30 degrees. We have this horizontal. If you can just look at that, it's very, very much important. Horizontal is very, very much important. You must know, where is it acting? Okay, that is horizontal. These are things that we're supposed to write down. If the object is displayed by 5 meters, now we have what? We have a displacement. This is a distance covered. Okay, 5 meters along a horizontal frictional surface. Frictionless, this is very, very much important as well. This word, you must know that there's no friction. So the object will just move freely. Is that clear? Even though there is a minimum friction that is happening there, but we have to ignore it. That is why they said frictionless surface. Okay, how much work is being done by the force? All right, what I need you to do, I need you to write down this question if you don't have a device. You have to write this down. For calculations, I'm just giving you 2 minutes. Okay, I will do it for you. If you can just look at that, we have an angle, we have a force, we have a distance. If you can just look at the object, moved from here to there. The distance covered is 5 meters. This is the information that you need when you want to approach this. Okay. We have to go back to mathematical definition of work. Like I said, before you get there, you must know that what is it given? Let me say we have data. This is the data that we are just going to have. That is 150 It's 150 Newton. Let me go back. We have 30. We have theta there, which is equals to 30 degree. And then we have displacement, which is equals to 5 meters. If you can just look at this is the information that has been given. We have been told that is horizontal. How do you know that is horizontal? I need you to have a Cartesian plane. If you can just look at that, we have a vertical upwards. We have, this is horizontal. Let me just write H. Capital letter H. That is capital letter H. This is capital letter V. This one stands for vertical. This one stands for horizontal. If you can just look at that, in other words, you're just going to have an object. This is the origin. It's the beginning of everything. This is the object. Where is it going? It's going to that direction. Is that clear? Okay. It's horizontal. But now you have to ask yourself, we have an angle. Can be pulled like this. We have been given 30. That is the force there. Are we together? All right. If you can just look at this, I just want to go back to our mathematical definition of work. We know that our work is equal to the force applied that is cos theta. Okay, we know that we have been given the force. We have been given the displacement. What I need you to do is to substitute all the given information to this mathematical equation. Okay, we have 150 in Newton. We have 5 in meters. We have cos 30. Okay, obviously I told you that we're supposed to have some of the gadgets that you are just going to use. Calculator is one of them. Now I need you to have this answer. I can just work it out for you. Obviously, you're going to get 6, 4, 9.5 in what? In joules. Or you can just do it like this. Before you get there, you can say that is a Newton meters. This is what you have. If you go down, you can just have 6, 4, 9.5 in joules. All right. Sometimes you can just say, I don't want to write in joules here. You can say, I know the Newton. Newton, a force, according to Newton's second law, a force is equals to, let me just show you here, F is equals to MA, mathematical expression of Newton's second law. Okay, we have mass and acceleration. That is the product. If you can just look at that, you are just going to get a Newton. This equals to Newton. Now you have to know this mass is going to be measured in what? In kilograms. You have to come here and say this is kilo kg multiplied by this acceleration is going to be measured in what? In meters per second squared. All right. You have to say over squared. This is your Newton. This is your Newton, and then you have your distance there, which is equals to 649.5. Meter squared per second squared. Let me extend my page. Okay, if you can just look at that, we have this unit. Whatever that you are going to get here is going to give you joules, 649.5 joules. In the multiple choice, they can just give you kilograms, that is meter squared per second squared. They ask you, is this a unit of work or what? They can give you different ones. But I need you to bear in mind, if they can give you this, you must know that this stands for joules. Where is it coming from? It's from Newton meters. Is that clear? Until you reach there. We have to go back and ask ourselves, is this a positive work or negative work or zero work? For positive, all the time, I told you that theta is supposed to be less than 90. Because it's less than 90, we automatically having what? A positive work. Is this clear? All right. Okay, let us go back. I just want to show you the answer here and how we reach to positive. This is what I was just doing, trying to show you how you get the positive 649.52. Okay, if you can just look at the answer that I gave you, I said 649.5 is the same as 649.5 joules. Okay, remember that the work done by a force on an object is equal to the energy transferred to the object. That is the definition of positive work. All right, I hope we are still together. All right, we have another example here. I need you to work. This is an assessment. I need you to do it. I'm giving you for those that they have a smart devices, they can just look at it. If you don't have, you have to write it down so that you can just have this work for your revision purposes. All right. Okay, I have to press start so that you can just log in. I just want to see. Okay, like I said earlier, when you come across with some questions when it comes to physical science, I need you to bear this in mind. Write down the given information so that it will be easy. You are investigating now. What is it given? What are they looking for? So I need you to write down everything. If you can just look at that, what is it given? I need you to look everything. There are conditions that you're supposed to look at all the time. I'm giving you only 5 minutes to do this. An airline passenger pulls a wheeled suitcase, exerting on a force of 65 Newton at an angle of 40 degrees to the horizontal for a distance of 5 meters. The amount of work done equals, we have answers here, it's a multiple choice. We have A, which is positive 249 joules, B, which is negative 249 joules, C, we have positive 24.9 joules, we have D, which is negative 24.9 joules. If you work out and get something different from this, you must know that it's incorrect. Because whatever that we're going to get is supposed to be close to this. Three minutes left. 3 minutes left. Two minutes left. Okay. So all the time, I need you to go back to the mathematical expression of work, which is W equals to cos theta. You can ask yourself, why this equation always cos theta, not sin theta? I need you to revisit trigonometry in mathematics so that you can just understand where this is coming from. I will show you if I have time. If I have time, I will show you cos theta because it's horizontal. You have to choose direction. If it's right hand side, it's going to be positive. If it's left, it's negative. Okay. If it's 180 degrees, cos 180 is going to give you minus. It's where you can just say, okay, this is negative. It's more than 90. Okay. This is the formula. A minute left, a minute left, a minute left. Time up. Okay. If you can just look at this, I said you start by writing down all the given information. If you can look at this, we have a force of 65 Newton. we have an angle which is less than 90. We have a distance, displacement, which is 5. The amount of work done equals to, now we have to work out. We have to work out 65, 40. Okay, we are left with 5 minutes to finish this. I will try to move fast so that you can just see how we reached there. Okay, if you can just look at it, we have what? We have 65 Newton. We have, is it, I think it's 5. Okay, that is 5 meter and 40 at a horizontal is 5 meter there, and then we have cos 40. Obviously, we know that this is going to give us a positive work because it's less than 90. All right. I need you to write all the units so that you are not going to have problems at the end. Okay, we have, you can say no, let me ignore the units. As long as you are going to have a joule at the end, it's okay as well. But what I need you to do is my advice, very, very much important, so that you're not going to forget the unit at the end. Because sometimes you can just get the answer without a unit. All right. Let me do calculations for you. That is 65 divided by 12 cos 40. Okay. If you can look at that, we're going to have what? Is 248.96. In what? In joules. Now you have to ask yourself, is it positive or negative? Because of that angle, we know that is positive. Okay, let us go back. If you can look at this, the answer there is A. The answer there is A. It's very, very much important to indicate, is it positive? Is it negative? At the end there, of course, most of you got it right. You got it right. I have less than a minute. What I need you to do, I just want to wrap up on this. Today, what have you learned? That is work. How do you define a work? After that, we have types of work. You have learned about the positive work. And this work has conditions. Think about the theta. Is it greater than 90 or is it less than 90? If it's less than 90, that is positive. And we have learned that positive work, that is the transfer of energy. That is the transfer of energy to an object. And that object will move faster and faster as it moves along. Okay. Thank you very much for being part of Smart, hellosmart.com.